My name is J. Austin Hughey. Just call me Austin. I work at Engine Yard. I'm on Twitter. Follow at your own risk. I'm kind of a jerk, and I shoot my mouth off a lot. And I also organize the local Austin chapter of OpenHack. We're at OpenHack ATX. Of course, Engine Yard is also on Twitter. For those of you who may not know, Engine Yard is a platform as a service. You toss up your code, and we provision instances for you. It's a bit different than Heroku is probably what a lot of people know. Heroku is a multi-tenant environment. We're a single-tenant environment. I'll tell you more about that later if you want to hear it. Let's talk about Rails 4. So let's talk a little bit about what happened here. This launched today. Rails 4 is out on rubygems.org now. I encourage you to go play with it a little bit, tonight, tomorrow, whatever. A lot of things have been kind of separated out from Rails 4 and put into their own little gems. They're kind of deprecated a bit. There have been a minor HTTP semantics change. Some security features have happened. There's some Postgres integration that's pretty cool. I should also mention this talk is not going to mention every new feature, just the ones that I find interesting. So, going on here. First thing you need to know, Ruby 1.9.3 is the minimum. If you're on 1.8, stop. Please. Seriously though, 1.8 is, if it hasn't already EOL'd, I thought it had, but if it hasn't already, it's going to very soon, which means no security updates, which means you're basically just standing there, at the end of the hockey goal with no pads on and just looking at the puck staring straight at you. Rails 5, however, according to DHH's post today, is going to require 2.0 or greater, so you might as well go ahead and upgrade now. They recommend 2.0 because it is faster. So I do recommend that if you can. A lot of things, like I said, have been separated into their own separate gems, some of which may or may not be compatible with Rails 4.1. We'll kind of have to see how that goes. So use them only as a bridge. Do not rely on them permanently. Just use them to get yourself from point A, wherever you are now, to point B, which is current with current best practices. We're now using the patch verb instead of put inside REST resources. We'll get to that in a bit. Strong parameters is now how we're doing mass assignment protection. I'll go over that as well. And thread safety by default is something that is going on here. So we're going to start by saying goodbye to the bears. Goodbye, bears! See ya. Anyway, I was like, I want funny gifts in this. So I found some. We're going to say goodbye to some features. Some stuff that's been removed in 4.0. Vendor plugins is dead. It's gone. Thank God. Use gems instead. Active resource has also been kind of moved into its own thing. Some of the things I read about that claim that they kind of felt it wasn't being given a whole lot of love that it really needed. So they kind of moved it into its own project. Hash-based and dynamic finder methods, that's where you had stuff like user.find and then you passed a conditions hash. That's its own thing. It's called the active record deprecated finders gem now. You can, as I recall, that is a dependency of Rails 4.0. It will not be a dependency of Rails 4.1. So when you start seeing deprecation warnings, pay attention to them and do something about them. Active record session store is also going by the wayside. It's not as efficient as using a regular old cookie. It's generally not considered the best practice to use anymore. Observers are also moving away. What I read basically said that they were being abused as a dumping ground for persistence operations that were better handled as a callback anyway. So like, after save, blah, blah, blah. And that they were also being abused a lot for cache expiration, which thanks to the way that Rails 4 is doing caching now, which is also why we don't need page and action caching anymore, or they've been moved, I should say. We don't really need those particular functions from observers, and that's pretty much all they really found that they were being used for. And I'll go into a little bit of detail, just the tip of the iceberg on caching later, but let's talk about the patch verb. This is a minor HTTP semantics change. So the hypertext transfer protocol specification says when you're going to send up a put request, it has to represent a complete representation of that object or resource, the whole enchilada. Now think about it. In reality, how often do we really do that? If you have a very trivial problem domain, a very simple form, you might automatically have everything that, you've got name, address, phone number, and that's it, right? And maybe that's all you've got. You click submit and it goes up. Well, you just happen to be compliant with the specification by accident, not because you actually were intending to. In reality, with real domains, real problem domains, we send up only the bits and pieces that we want to change, especially when it comes to other bits of access like APIs and such. So we've been using put wrong. So that's why Rails said, well, let's just use the patch verb instead, because that's the right way to do it. The patch verb says, send me the bits and pieces that you want to change. Now, in 4.0, this is like if you have resources, whatever, that should be in there automatically. But remember that if you have any specific routes that are saying, here's a put request to blah, 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 make sure to update those to patch, as well as anything that you've got with, form helpers, form for blah, method put, change that to patch. Rails 4.0 should work with put as well as patch as a backwards compatibility effort. But wherever you start seeing put and you mean to do an actual update to an object, start changing it over to patch now. Let's just get current with the best practices and not worry about it. All right, let's talk a little about thread safety. Now, concurrent programming is something that is outside the scope of this talk. It's very, very complicated stuff, and I am far from an expert on it. But I want to go a little bit into detail here because I think it's going to shape the future of the Ruby community to an extent. Now, arguably, maybe even not arguably, Rails is probably the largest, known Ruby library out there, a collection of libraries. And they have just shipped this thing today that says config.threadsafe is on by default. Now, what does that mean? Well, see, Ruby has this weird little thing called the global VM lock or the global interpreter lock. It can only execute one bit of actual Ruby code at a time, not multiple ones. Now, you can spawn new threads inside Ruby, and that's cool, but when it actually comes down to really executing that code, it's only going to be one at a time. Now, there are alternative implementations. JRuby and Rubinius, for example, are both Engine-Yard-sponsored projects, and they do not have that limitation. But the reason this is important is because it sends a clear message to the Ruby community in general that, hey, we're serious about concurrent programming. And maybe, I don't know if it'll actually make any real changes in terms of Mass Ruby Interpreter, the canonical Ruby that we all know and love. But it might drive a little bit more adoption of things like JRuby, Rubinius, and thread-capable servers like Puma or Passenger Enterprise. Now, the free Passenger, the one you actually pay for. The bottom line with this is that you have to make sure that not only are you running against an app server that is capable of multiple threads and multiple connections and so on, your interpreter has to be able to do that too. And you have to make sure that all your dependencies for your app, so not only your app code, but Rails, everything Rails depends on, and everything you depend on, everything in your gem file also has to be written in what's called a thread-safe manner. So that's just something to bear in mind, but I think it's an important signal to the Ruby community in general. All right, we're going to move on and talk about strong parameters. This is the way we're doing mass assignment protection in Rails now. Before, this is how we were doing it. Basically said, here's a model, here's adder accessible, and here's some params. Cool. We just threw whatever the hell we wanted at the model, and it knew exactly what to do. It was all good. This is a little bit problematic, though, when you start working on the back end of things. When you have a complicated problem domain, when you have a big application, a lot of data, every now and then you do have to get in the back end and start fixing stuff. And not to mention development and tests can be sometimes a bit problematic with this. So, DHH basically said, how can we get that mass assignment protection? Because it's not optional, we have to have that, but still allow for some very easy, very flexible manipulation of the model. And basically they came up with this thing that they call strong parameters. So instead of what we just saw, picture this situation where we don't even care about adder accessible or protected, it doesn't matter. Nobody cares. Instead, we've moved that protection from the model layer into the controller instead. So think about it this way, it's a web application framework, right? It's not a desktop app, it's not a GUI app, it's not a console app, it's a web app framework, which means you have two possible input vectors, user, developer. User input can never be trusted, ever. Developer input has to be trusted. So we don't need this stuff getting in our way. So where does it make sense to guard against bad input? In the controller. So that's why this has been moved. So what we have here is, here's an example. You have a controller, a create action, we're instantiating a new article object. And instead of before, we would pass it params article, right? That's just a straight params hash coming from, Now, instead, we're going to pass it this method. And you can call this whatever you want, but the actual convention is called whatever the model name is, _params. But anyway, you basically say params.require article. So inside the params hash, I'm requiring that there is an article hash inside there. And inside that hash, I want to permit only these keys, the title and body key. That is then sanitized and passed to this article.new method, instantiating the article. Now, if I were trying to hack this and I wanted to spoof, let's say, the author ID of this post, I might send via curl or other means a hash that says here's an article, here's a title, here's a body. Oh, and here's an author ID too. I'm just going to make this some author, whatever. What would happen is this hash would basically reject that entirely. It would say, I don't care. It's going to strip that out, sanitize it, and permit only these keys that I specify, and then have it come into there. That's things like other security measures withstanding, of course, but theoretical example. That's basically how it works. Like I said, so why is this better? Because it frees up the developer to work on the data model uninhibited, and it puts the focus on the user input vector, which is the controller. Criticism of this is that, I was talking to somebody about this several months ago, and I told him, I like this idea. He said, I don't. I said, why? He said, in purist theory, we should be able to take an object of any kind and pass it any input we want, and just trust and know that it's going to know exactly what to do with that input, no matter what. So this definitely breaks that pattern. Personally, I don't care because I'm looking at the larger picture and thinking, well, it's a web application framework. That's how it's going to work. But that might bother you, so just bear that in mind. Another thing is that one thing that I read, I believe by DHH, said that he didn't intend this to be a silver bullet, fix all, something that is going to protect against everything. So you might need to implement other methods in addition to guard against bad input, depending on what you're doing. And one thing, I haven't tested this with nested attributes myself yet, but I've heard from others that it can be a pain in the rear end. Doesn't work very well for some reason. I believe there might be a way around that. I seem to remember something, but I don't know off the top of my head, so bear that in mind. Another thing about, I couldn't make an talk about encryption without making an NSA joke. I couldn't help myself. Anyway, so the thing about this is that another feature is encrypted cookies. The idea is it's a default cookie store in Rails 4. It's a new cookie store. It just encrypts cookies before they go out, decrypts them when they come back. The idea is basically to prevent user tampering. Obviously, don't put any sensitive information in these things. They're cookies, for crying out loud. They're only going to support 4K anyway. And yeah, it might annoy the NSA. Just saying. Probably not too much, though. Default headers. This is something that I saw that was kind of billed as more of a security feature, but I think it's more than that. So these three default headers we see here, frame options, cross-site scripting protection, and content type options, are default with Rails 4. Now, obviously, since they're just headers, you got to depend on your browser to care about them. It's never going to stop an actual attack. But the fact that they're there is kind of cool. Now, there's no reason that you couldn't do this with Nginx or something like that. Add these headers on outgoing responses anyway. But maybe you're in an environment where you can't modify, Nginx config for whatever reason. That might be a good alternative for you. Now, I see other options that you could do here. Maybe you're writing a mobile app, for example, and you want to, I don't know, have a pre-shared key of some kind that, when you launch the app, it comes up with a derivation of the key and sends that derivation down, with every response. I'm not a cryptography expert, but you get the idea. It allows your mobile app to figure out, oh yeah, this came from the right source. You could do that. The thing to remember is that, to the best of my knowledge, and feel free to fact check me on this, if I'm wrong, tell me, and tell everybody else too, that to the best of my knowledge, this is not going to be parsed on each response. It doesn't make sense programmatically or performance-wise. It doesn't make sense to parse this on each response. You only want to do it when the app launches. So if you have something here, another argument that you want to vary on each response, you're going to have to do it on the controller level anyway. But the automatic default headers, if you have something that's just a single value and you want to push it down on every response, you can do it this way. So it's an interesting feature. Let's talk about the elephant in the room, PostgreSQL. For a long time, Rails community has been using MySQL a lot. We're kind of starting to see a bit of a love affair going on with Postgres, because can you really blame it? There's a lot of cool data types that Postgres supports under the hood, a lot of cool stuff that you can't really do with MySQL, at least not without a lot more pain. For example, the HStore data type, arrays, INET, CIDR, MAC address, UUIDs. To the best of my knowledge, you can't really do those very easily with MySQL, if at all. So let's talk a little bit about, let's start with HStore. Basically, this is a database extension for Postgres, but Rails has some cool support for it. You can actually use it in a 3.2 app with the active record Postgres HStore gem now. And in fact, that's where I tested some of this stuff, was on one of those apps. If you've ever done a column serialization thing with Rails before, this is kind of similar. Normally, what you would have is a big old text column in a MySQL DB, and you just shove a bunch of serialized stuff in there. Maybe it's a JSON hash, maybe it's some YAML, whatever. With Postgres HStore, you can actually store it much more efficiently. You can index it, and you can query it. You can do a lot of cool stuff with it that you couldn't otherwise do with a MySQL version of that. Now, talking about those indexes, you've got two types. You've got gist and gin indexes. And you should read the Postgres docs to figure out what's up with these, but I'm going to tell you from memory, so if this is a little bit off, forgive me. Gin indexes are going to be slower to build, larger on disk, but they're going to search faster than gist indexes, but there's a catch. Gin indexes, the search speed depends on the logarithmic difference in unique words. I believe that's how it's stated in the Postgres docs. So I was writing an article about this. It hasn't actually gone anywhere yet, but I thought, what's a good use case for, an HStore thing inside your app? I thought, okay, what about user preferences? Let's say you've got an app, you want to have user preferences, and you want to stick those, serialize those, HStore-wise. Well, you might have a known set of preferences, like language, color of the, style sheet or whatever, currency, and you might have, maybe, so you got 3 preferences, 3 keys, and 10 possible values per key, maybe. So this is why you need to read the docs to figure out which is going to work better for your app, because in this case, you would think that maybe a gin index would be better because it's going to search faster. Not necessarily. Again, logarithmic difference in unique words. So we've got a data set with not a lot of unique derivation. So a gist search or a gist index might search just as fast as a gin index, but be smaller on disk and faster to build the indexes. So you might be better off with gist. The querying interface, I feel, is a little bit weird syntactically. That's just my opinion. But you've got, like preferences, add greater than, theme black, whatever. Like I said, you can do the Postgres, active record Postgres HStore gem with that now. The array data type for Postgres, you basically, in your migration, say, I want an integer, call it this, and we're going to say it's an array. You're going to pass a Boolean telling that it's an array value. Same thing with the string, whatever. And that basically tells Postgres it's going to be integer data, it's going to be string data, but we're going to pass an array. And of course, you just use it like this very simply. Give it an array, save it, done. INET CIDR and MAC address, very similar things here. Those are 3 unique data types in Postgres. They are 2 unique data types and 1 generic one in Ruby. So CIDR and INET are both going to be instantiated and come out as IP adder objects, which is something in Ruby 1.9, I believe, is where that debuted. MAC addresses are just treated as strings inside Ruby and in Rails and Active Record. But once they actually go into the DB, they're stored according to those native data types. Moving on, UUIDs. I like UUIDs. Yeah, all right, represent, man. UUIDs, right on. Anyway, I like UUIDs. You can use them in a service-oriented architecture all over the place. They, lots more room. So you can use these with Postgres. Now, in MySQL, you could sort of fudge your way through it. You could store them as strings, but then they have to be indexed, and it can get really messy. Whereas here, it's just a native data type. So the first thing you have to do is enable an extension UUID OSSP. Bear in mind, whenever you're running something like enable extension or a create extension command in Postgres, you're going to need to be probably a super user or an admin of that DB, which is not a problem unless you're not practicing good network layer security and or you have multiple DBs on the same server. If you do, and you're, somehow you end up with some kind of a weird injection bug that even bypasses Active Record, you could end up jeopardizing other people's data, if that's the case. But if not, it's fine to just do it like this, enable extension. Otherwise, just like, do a custom chef recipe or something. Anyway, you basically say create table, whatever, and then pass it an ID argument and tell it, here's a symbol, UUID. And that's pretty much all there is to it. That's creating a UUID. Now, one of the key things to keep in mind here when you're doing this is that you've got methods like object or model.first, model.last, which generally depend on the floor and ceiling values of your ID field. Well, this is not a numerical value. A UUID is not a numerical value at all. You can't really do it that way. So you might want to introduce a default scope in your model that says order by created at ascending. So you get a chronologically first, chronologically last when you call those methods. Otherwise, it could break. All right, let's talk a little bit about Turbolinks. It's a cool little JavaScript feature. The idea is they want to speed up the client-side execution, the client-side rendering, make everything look nice and fast and better user experience for your users. What happens is this is included by default with Rails 4. You're going to click a link, and it's basically going to retrieve that resource from the server and swap out the body tag with what is actually, with what should be from the response. The benefit of this is that you don't really have to have the browser go through and reinstantiate objects in memory from JavaScript and CSS. You don't have to worry about any of that stuff. You're not going to have a whole lot of slowdown from the user's perspective here. So it's going to appear a lot faster. However, that's dependent upon one major factor. How much JavaScript and CSS have you got? Because if you don't have much, you're not going to notice a whole lot of difference. If you have a lot, you might notice a lot of difference. Like I said, it's on by default. Makes everything look faster, but beware, it could break some of your JavaScript depending on what you're doing. You might have to have things listen to different event listeners. And again, the CSS, the speed improvement is dependent upon how much CSS and JavaScript you have. I'm always amused at how much people rage over new defaults in Rails. I don't know if anybody remembers when Rails put out the defaults for CoffeeScript and Sass.
Rails 3 what?
Yeah, exactly, right? And people just raged over that in GitHub comments. It's hilarious because it's so damn easy to disable. You just delete 2 lines from 2 files and bundle. That's it. You're done. It's gone. So if you suspect that Turbolinks is a problem, instead of raging about it, just delete it from gem file, delete it from application.js, and type bundle and press enter, and you're done. That's it. Moving on. Talk a little bit about some caching here. Like I said, that was like the best thing I could find for this. Anyway, so caching, I'm going to hit just very briefly. So we have this feature called cache digest. Now, before you might have had to put a little version number or something into your code and bump it every time you wanted to push a deploy that changes the stuff that's being cached. You don't have to do that anymore, thank God. What they do now is they're computing an MD5 checksum of the stuff inside the cache when the application starts. So if the actual content there changes, you don't have to worry about version bumping anymore because the MD5 sum is going to be different anyway. So default test locations are going to change as well. And I was thinking, what's something fun I could put up for testing? And this is portals, pretty much the only thing that came to mind. You're going to have test models, helpers, controllers, mailers. This will probably be a little easier for you to get in and wrap your heads around than the original, which was test units helpers, functional. When I first looked at programmatic testing, I was like, why the hell does it have to be written like that? Why can't it be like the way it is now? So I think that might help newcomers to testing a little bit. Let's talk a little bit about live streaming. This is a new feature in Rails 4 by Aaron Patterson. The idea is to basically stream a response through a long running connection to the browser. You should be using a multi-threaded application server. Otherwise, you're going to have a single thread locking while it's streaming data, and other requests are coming into a Unix socket or whatever behind the scenes there, and they're just going to be sitting there waiting. So you do want to use it behind a multi-threaded application server. For example, maybe Puma, Passenger Enterprise. Thin may also work. I'm not sure. I believe Thin is evented, not threaded. But anyway, you want to put it behind a non-GIL addled interpreter, like I was talking about earlier, JRuby Rubinius, if possible. You can use this with Ruby 2.0. Standard Ruby should be OK. I don't know about the performance, though. I haven't seen a lot of examples of this in the wild yet, probably because for a while it was pretty much broken on IE, which is regretfully the largest market share browser out there. When this was written, the actual warnings about IE, I think it was IE 9 that was out at the time. We're up to IE 10 now, as far as I know. So that might not be true anymore. I'd encourage you to test it. But using it's pretty simple. You just include this action controller, live module, and then just say response.stream.write, blah, whatever. Do it inside of a loop, for example, and just close the stream when you're done. Pretty simple. All right, so let's talk about things that are not shipping here. Some people were expecting there to be a background queuing API. The idea was you had stuff like delayed job, rescue, sidekick, and for the most part they're fairly similar, but there are some differences. Rails, the idea is to take these things and provide a common API for them to hook into, and a common API for you to give your delayed or asynchronous tasks to, and then that way you can switch your backend pretty easily if you want. Unfortunately, that's not shipping. Some people kind of felt that was a little bit half-baked, so they moved it out to their own branch, their own feature for that. Likewise, asynchronous action mailer, same thing, because it depends on the background queuing API. So you're still going to be, for Rails 4.0, you're still going to be stuck with your rescue or sidekick workers. We're like and we're not like. These are two things for active record that we're kind of hope to have. So you could say where something is like blah or something is not like blah. DHH killed this feature. He listed several different reasons. He said that it opens the door to things like where greater or equal than, so which would be kind of a pain in the rear. He said they're not very commonly used, and so they don't really need a lot of optimization. And he said that the reuse percent signs wildcards felt like an odd syntactical conflict with Ruby. I'm going to go a little further than that, actually. I kind of feel that where you're doing where like and where not like, you're usually searching text, and you're usually searching wildcards around it. So what's going to happen is, unless it's very well indexed, you're going to end up slowing down your database, and even if it is well indexed, excuse me, at scale, you could end up with a lot of latency in your actual query. So it's going to slow things down in production. So when you're doing something like that, I highly, highly, highly recommend, instead of doing like that, have a search index like ThinkingSphinx or Elasticsearch ready to go instead, and use that instead of actual wildcard searches in SQL. Some advice for upgrading, very simply, pay attention to the deprecation warnings and do something about them. Don't just let them sit there. Make sure you've got a really good set of tests and really good test coverage. That is absolutely key if you want to upgrade safely. If you don't have that, I strongly recommend that you put off an upgrade until you do. Make sure you've got good tests. Take it in stages by sprints. Maybe you have one sprint and you say, okay, we're going to go from no tests to testing 50% of our code base, roughly, arbitrary number. Next sprint, maybe you're going to do new features. Then you do another sprint to get your tests up to date. You do another sprint for new features. You do another sprint for moving from, say, 3.1 to 3.2, and so on and so on. The eventual goal being, if you're behind 3.2, get yourself there, because from 3.2 to 4 is going to be the easiest upgrade path that there is. Just a little minor advice there. And that's pretty much it, guys. Thank you.